we're going to continue to talk about the quantitative section today. We're going to look at a few ways to approach questions and make sure that you're using good organized work, and actually also stop doing algebra. Just because the problem looks like an algebra question, you don't actually have to do algebra. So we'll talk about ways to get around that. That technique is actually called plugging in. Anybody here take an SAT or ACT prep course in their past? So I am going to be almost certain that since you did, you probably learned about the plugging technique, right? And basically what plugging in is doing is basically saying, okay, rather than actually doing like algebraic manipulations, I'm just going to pick numbers and test it out. So if it works on the SAT and the ACT, it definitely works on the GRE as well. So we're going to talk about that technique. So basically what we're going to be looking at today is how to approach most of the questions with the exception of quantitative comparisons. Actually, I think I do have quantitative comparisons in your own retrospect. So we do have quantitative comparisons in this today. So the first thing is when you see a question that has variables in the question, stem, and variables in the answers, this should be a trigger. So if you see this kind of a question with variables in the answers and variables in the question, you should think, oh, I can plug in. And what plugging in entails is simply picking values for these different variables. Now, there's some rules about this. You probably don't want to pick 1 or 0. Why are 1 and 0 bad choices for plugging in techniques? Like what's 1 squared and 1 cubed? Or what's 0 squared and 0 cubed? Just gives your original number back. That's right. So since you're getting your original number back, it won't give you good differentiation between your different answer choices. So you want to stick to stuff that's greater than 1. Negatives also kind of suck because, well, first off, working with negative numbers, kind of a pain in the butt. But also negatives can also just disappear. If you do negative 2 squared, it's just 4 instead of negative 4. So stick with integer values above 1. So for this question, what I chose to do is I just chose x to be 4, y to be 3, c to be 2. Doesn't really matter what I pick as long as I just pick them. So what does a equal if x is 4, y is 3, and c is 2? What does a equal? Just plug those numbers into the question stem and figure out what a equals. We got a 9. So it's going to be 2 times 4 minus 3 minus 2 times 2, which is going to be 9. Yep, following your order of operations quite well. So a equals 9. What is b going to equal? Do the same thing. Plug in your chosen variables in for b. Looks like that's going to be 1. So what does a minus b equal? Because that is what we're looking for. So a minus b equals 8. And then on your scratch work, you should circle that. That's your target. That's what the answer should equal when all is said and done. Because you chose these numbers and found what a minus b is. And the question is asking, what is a minus b? So now you go to the answers and you do the same thing. You plug in the answers for a. A is going to be -6 if I plug in my y value of 3. Is that the correct answer for the question? Does it match the thing I circled? Does it match my target? Nope. Let's get rid of it. Does B work? Does it? It does not, because B equals -8. My target was +8. B also would not be the correct answer, so I get rid of it. C was just 0. Does that work? Nope. D gives us +6. Good or bad? Nope. Let's get rid of that. And E, when I plug it in, was 4 times C. 4 times 2 is 8. There's my answer. There it is. I checked all my answers, and the only one where my target number matches the answer is E. So that's the correct answer to the question. Now, I know a lot of you are saying, well, that's a lot of work to do this. Doesn't matter. You have 1 minute and 30 seconds per question, a little bit more to do these problems. So time should never be a consideration here. What this does is it eliminates the silly mistakes people make because of like the slews of negative signs in this question, plus the fact that sometimes you just look at this and go like, I have no idea how to do this. And that's okay. You don't have to remember how to do algebra. All you really need to do is arithmetic, because all we did was arithmetic. The one caveat with this technique, you must always make sure you check all your answers, because the numbers you picked might have given you a situation where 2 of the answers give you the same value. And if that's true, you eliminate down to those 2 and then just pick a different set of numbers and then plug those in instead. But it's basically it turns a algebra question into a arithmetic question, which makes it more or less a no-brainer. You don't have to actually think about anything. You're just doing manipulations with numbers. So I encourage you all, anytime you see what in the question stem and what in the answers, to do plugging in. What's in the question stem and what's in the answers? Variables. When variables are in the question stem and variables are in the answers, you can use plugging in. And I'm using this idea of like trigger and what the response is. When you see that trigger, then you know to do this. There's a different trigger you might run into, though. Variables in the question stem, but numbers in the answer. We can still use plugging in, but it's actually a little bit easier because of this. So here's what I mean. An office supply store sells blah, 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 blah. What are the variables in this question? There are variables in this question stem. It doesn't look like there's variables in the question stem, but there are. What are the variables in this question stem? Yeah, the number of clips, but be more specific. It's not just the number of clips, but the number of $0.14 and the number of 16 cents. So they're both in there. This is what I like to think of as a hidden plugin, because the variables aren't stated explicitly, but they're phrased in the words. And this is a common structure for these kinds of questions. You'll see the variables aren't evident necessarily because they don't write them out. They just give you an implication that there's a variable in here. And what variable are we asking to find, or is the question asking us to find? we're being asked to find the number of 14-cent clips. And those are what all of my answer choices are. And so what plugging in the answers means is I'm going to take my answer and work the problem backwards. It's kind of like doing a maze backwards. Doing a maze backwards is way easier than doing the maze forwards because you see all the pitfalls. So if I start with the answer choice C, and that's where we should start. We should start with answer choice C, always on these. Start in the middle and work your way out. The reason for this is the answers are ordered in numerical order. They are almost always going to be from smallest value to largest value when you go from A to E. So we can use that to our advantage. So if I start with 30 small clips, how much did it cost for those 30 small clips? How much does it cost for those 30 14-cent clips? What's the math I got to do? Yeah, $4.20, because I'm going to be spending 30 or 14 cents on each of the 30, which means I'm going to spend $4.20. Okay, that's good. How much then? How many 16-cent clips am I going to have? If I have 30 14-cent clips, how many 16-cent clips do I have? I'm going to have 55, right? Because 85 total clips minus 30 14-cent clips means I'm going to have 55 16-cent clips. So how much do the 55 16-cent clips going to cost me? Not 1467. That's a little, that I'm not sure what you multiply to get that. I would agree with 880. I think that might have been a typo, like in your calculator. And plus, you could use your calculator on this, right? It's just doing basic arithmetic. So you're going to have $8.80. So 55 times 16 cents. What does that add up to? $13. So is C correct? Nope, because we actually spent $13.10. Okay, so let's use some logic here. I have less in my answer than in what's in the actual answer, which is 13.10. So do I have too many 14-cent clips or do I have too many 16-cent clips? I have too many 14-cent clips, which is why it's too cheap. So which other answers are definitely wrong at this point? Which ones can I also cross out? D and E, because 35 and 65 are even bigger, which means it's going to be even worse. So this is why you start with the middle answer, because in many problems, you can make a judgment call and say, this is too big or this is too small. And so therefore, you can eliminate 3 answers at once. Boom, boom, boom. Now, how many answers do I have to test to determine my correct answer? I only have to test 2 total because I tested C. And then if I try B out and it's not B, what is the correct answer? It must be A. So overall, we only really have to test 2 answers using this technique. So let's just move up. I do it systematically. You could try A if you feel like it. It doesn't really matter. Try one or the other. I tried 25. So 25 14-cent clips costs me $3.50. And that means I'm going to have 60 clips at 16 cents, which was $9.60. So what does that add up to? $3.50 and 9.6. Up, that's $13.10. Does that match our question? Yep. So my answer must be answer choice B. And there we go. So the whole idea about plugging in and either plugging the answers or plugging in the variables is really so I just make the question simpler. I don't have to figure as much out. Like working with dollars and cents for most people is generally an easier task than solving an equation. I mean, to do this technically, I would have to set up two equations with two unknowns and then solve the equations with using the elimination or the substitution technique. And for a lot of people, that actually takes more time than doing what we just did. So there is value in dumbing down the question, so to speak. We're not going to do the question the way they want us to do it. We're going to beat the system. So how do I recognize what's my trigger for plugging in the answers? There's blank in the question and blank in the answers. Blank in the question and blank in the answers. Variable in the question, numbers in the answer. That's right. So again, like we go back, variables in the question, variables in the answer, plugging in the variable, variables in the answers, questions, numbers in the answers, plug in the answers. And these are very common questions on the GRE. GRE. Hey, you can do it. All right. Now, what about averages? Average questions kind of mess with people. They're not hard, but sometimes it's hard to wrap your mind around it. Anybody have an idea how to solve this question right away? The average of 7 numbers is 9. The average of 3 numbers is 5. What is the average of the other 4 numbers? Anybody just intuitively know how to approach this thing? It's what I usually hear. Not a lot. So let me teach you a little trick called the average pie. When I see an average in a question like this, draw an average pie and fill in what you know. And what all an average pie is draw a circle in your scratch board, scratch work, and put a horizontal line and put a vertical line in it like this. The things in the average pie are the sum, the number of items, and the average. And the reason we organize it like this is because sum divided by number gives me what? Sum divided by number gives me what? Gives me the average. Average times the number of things gives me the sum, and sum divided by the average gives me the number of things. So what this is called is a graphic organizer. We're organizing the things into a rational way, in a rational way that allows me to do something with it much more easily. So for the first one, I'm just going to fill in my average pie for the first average. So what should go in my average pie for the first one? In the top, do I know it? Do I know the sum for the first average? Well, how'd you figure that out? How'd you figure it was 35? Because you actually aren't given it. It's not in there. You'd have to figure it out. And that's what the average pie is for. Because all I know for my first one is I've got 7 items that have an average of 9. So what is that sum? It's actually 63. Yeah. Then for my second average, I can write an average pi. And that's going to be, I have 3 numbers that add up to, or that average 5. So what's that sum? That's 15. Okay. So I'm kind of seeing what I might need to do here. And then we can do arithmetic with average pi's. So we're taking away those 3 numbers from the 7 total, which means my new average pi is going to have what in it? What's going to be in the what's the new sum? 15 away from 63 is what? 48. So my new sum of the numbers is 48. And I'm now going to have only 4 numbers. So what's my new average? (48) divided by 4, which is going to be 12. There we go. So do you need to draw the average pi's to do this question? Nope. Does it help you remember that you can find a sum from an average? Yeah, that's the thing. I think that most people forget with averages is you can actually find a sum from an average in a number of things. And that's what these questions are sort of predicated on a lot of times, is knowing that you have a sum here and then the sums you can do math with. You can't just subtract the 2 averages, because 9 minus 5 does not equal 12. It's a little counterintuitive that that's how the answer would go. But if you remember that the sum is there, there you go. And that's why we use things like average pi's. That's why the whole point of this lesson is like techniques to help you approach questions and remember how to do things that you haven't done in a long time. And just honestly to make them easier. And guess what? There's more than just average pi's. We might also see that there's a rate in the question. I'm sure you've seen these questions before about you have a machine that can do this in this time, or 2 people are mowing a lawn. One person can mow a lawn at this rate and the other one can mow a lawn at this rate. I don't know how much time would it take them to do it together. And so we can use rate pi's. All a rate pi is the same idea, because it has the same relationship as average does to its parts. And I can put the amount of work here, and I can put the time here. And what's work divided by time? Not number of things. Rate. Yeah. Rate is just the amount of work that you can do in a certain amount of time. I can go 50 miles in an hour. I can stamp 20 envelopes in 4 minutes. And so it has the same relationship. Time times rate equals work. Rate or work divided by time equals rate. Work divided by rate equals time. Do we have to draw these rate pi's? No, but can it help us organize our thinking? Heck yeah, totally. So fill in what you know. So for my first machine, what do I know? Do I know the rate, the time, or the work? Which of those things do I know for my first machine, or for the machine? I know the work it can do and how long it takes to do it. Right. So I can build a rate pi for that says 20 over 4. Okay. Well, what's the missing thing? What's the thing I can find? I can find the rate. So what's my rate for this machine? It can do 5 stamps per minute. You can do 5 envelopes per minute. So rate of 5. Okay. How many of these machines do I have? trying to figure that out, right? I could use the answer choices, or I could logic it out too. This is a good example of a plugging in the answers question, isn't it? There's an unknown in the question. So yeah, I would start with 12. I would start with 12, multiplied by 12. What will change in my rate pie? If it can do 5 envelopes in 1 minute, how many can it do if there's 12 machines? It can do 60. So there we go. What's my answer? C. So here we're combining techniques together. We can use plugging in the answers and rate pies together, because all I had to figure out is how am I going to do this 60 envelopes per minute thing? So what am I going to multiply the rate by to get 60 envelopes per minute? So it's all about organizing your thinking. Organizing your work like this way, like doing it this way, isn't necessary, but it helps you be more mindful of what the problem is asking you to do. It'll help trigger memories of what it is that you know about these things. The rate pie, the top is going to be work. The bottom left is time. And the bottom right is rate. And remember, like top divided by bottom gives you the other side. And then the bottom two multiplied gives you the top. Another type of question, and these I've seen people just have no idea how to approach these, is when they introduce a ratio into the question. You're like going, oh, garbage. I have a typo. I have to fix that. They look at these and go like, what do I do with this ratio? I have no idea. Let's find a way to organize the work here too. I'm just going to call this a ratio box. So you see ratios in a question. First thing I'm going to do is pop a ratio box in there. So ratio box is going to consist of a couple parts. First, your sort of item row. We can call that the item. And at the end, you're going to have a total. So for this one, we've got flour, eggs, yeast, and salt. And I will tell you, on the way the GRE works, almost always they'll make sure that the first letter of the different things in a question are going to be different than each other. So you can usually just label stuff instead of the whole word with just the first letter of it. It's almost always going to be that way. Like if they have a question on people, it's Adam, Barbara, and Chuck, because they just have 3 different letters starting with that. So then my second row is going to be the ratio. So they gave me a ratio. 11 to 9 to 3 to 2. And then they're telling me how many pounds of yeast are there in 20 pounds of the mixture. So that's my actual amount. So I'm going to put my total, which is 20. And then just start filling out parts of the table. So what could I get from what I have now? What other box could I fill in here? Yeah, I can add up the ratio row and get a total from that. So what is my total for the ratio row? $25. And so how do I know that I can do that? Is that every time I have one box left in a row or column, I can find out what that extra box is. So since I had all 4 of these, I could find the 5th one. So what can I find now? Because I have one thing missing in any given row or column. I can find what my multiplier is, because I have 20 and 25 25 times what fraction would give me 20? Because you're thinking of the multiplier is literally that. Ratio times multiplier equals actual 0.8. Yeah. That would be 0.8 or 4/5. But the thing about the multiplier row is once you know the multiplier, is it going to change across the whole table or is it always going to be the same? It will always be the same. It doesn't matter how you find the multiplier. Once you find the multiplier, it's going to be the same for the whole table. So it's 4/5 all the way across. So what can I find now? I can find all the actual values. The one I'm most interested in is yeast. So what is going to be my actual value for yeast? Three times 4/5, which is 2.4, which is which of the answers? It's going to be answer choice D. And there we go. So ratio questions actually are fairly easy to do once you pick up on what they're giving you. Sometimes they don't give you the ratio. Sometimes they're asking for the ratio. So they'll give you the multiplier and they'll give you the actual quantity. Sometimes they'll give you the ratio and the multiplier and expect you to get total quantities. Sometimes they'll do like this one, where they'll give you the ratio and the total, but the actual, but they won't give you the multiplier. And that's what you got to figure out to solve the rest of the question. Whatever the case is, they're going to give you at least two of the three pieces of information that you can find. The same goes for ratios and the same goes for averages because they got to give you at least two of the three things to make the problem solvable. So the ratio box, there you go. And then finally, let's finish up with how do quant comparison questions work? Quantitative comparison questions are at their very heart like work or not work questions, but organization questions. Sometimes, most of the time, you have to try several scenarios to be able to solve the question correctly. So here we've got, here we'll always see the answers are always the same. They'll give you two quantities. Then you got to figure out if A is greater or B is greater, if they're equal or they cannot be determined. At a certain point, sometimes you can't actually determine it explicitly. So how do I know when to move on to D and like say it's going to be cannot be determined? Well, you can't know 100% because cannot be determined is something hard to prove. But the way I do it is I usually try three scenarios. And if the results between my three scenarios, like say my first scenario, A was greater, my second scenario, B was greater, what's the answer to the question? It's got to be D, because if my two scenarios don't match each other, if I find a different result from each of the scenarios, then the answer must be D, which means it cannot be determined. If I try three times and I find the same result every time, I've got to trust that it's always going to be the same. I got to say that it's always A is greater, because there's times where you might be guessing scenarios where you can try it 3 or 4 times and you might find the same thing, and you might have not actually hit a scenario where it is actually cannot be determined. You got to let it go. At some point, you got to say like, okay, it's A is greater, gonna move on, even though I have a feeling it's probably D or something like that, because you just can't know for sure. There's no way to 100% in those scenarios, this kind of a question. So never try more than 3 scenarios. If you do this, if you try 3 scenarios and you get the same result every time, just go with that result, period. Do not pass go, do not collect $200. So here's an example of a quantitative comparison question. Mr. Andrews' test consists of 10 questions worth 10 points each. He also gave an extra credit question. So they usually have a prompt like this before they give you your quantities. So the first quantity is A, the extra credit value from picking the first option. So that first one is the first test for it to be equal to the student's average individual question score. So what is that? Do we actually know what the student's average individual question score is? We don't. So we have to actually pick a scenario for this, right? So what are the scores on the student's individual questions? Let's be smart about this. Don't pick weird numbers. Pick something very simple for your first scenario. What's our first scenario here? What do you guys want it to be? How many points per question does this person get? 2 points a question? Okay. So he gets 2 points for every question. Boom, 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 boom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is scenario 1. So what is A for scenario 1? What's my value of extra credit for scenario 1 for A? First option. It's going to be 2 because the average test or average question score is 2. Okay. What is B going to be for this one? It's the median individual's question score. It's going to be 2 because my median is what number again? It's the middle number. Does this set of scores have a middle number? Let's make sure we remember this about median. Nope. So what do you do in that scenario? You average the 2 numbers to find the median. The median would be 2. All right. So right now, what are we believing? A is greater, B is greater, or equal to each other? Equal to each other. All right. Scenario 2. Let's try another scenario. What scores do we want to have now? Again, work smarter, not harder. Do I want to change all the numbers or do I want to try to change one of the numbers? Like, use what you know about means and medians to adjust your data set. Is there a way I could alter the mean without altering the median or vice versa? Okay. 2, 2, 2, 2, 2, 2, 2, 2, 2, 4. So he does better on that last question. He's still doing terrible on this test, by the way. We're being mean to this kid because like he's only getting a really, really low score. failing class. So what's my A quantity for this one? And we can fudge it. We don't have to actually calculate it if we all of a sudden realize what's going on. What is my average? 2.2. It's slightly greater than 2. What is my median? It's going to be equal to 2 again. So now what's happened? Is A greater, B greater? So A is greater than B. So what's the answer to my question? It's going to be D, because it cannot be determined. That's right, cannot. And so this is the answer choice I would select, because my two scenarios were inconsistent with each other. They found a different result, and therefore the result cannot be determined. A is not greater than B, B is not greater than A is not equal to B. And boom. So I know this is a fairly simple question, but the technique is all about organizing your thinking. So let's talk about a little bit about the work. Notice what I did. I labeled my first scenario. I explicitly wrote out my values, and I explicitly wrote out what I was thinking, A is equal and B is equal, and what I felt the relationship was. And then I again did it for the second scenario. And so when you do it this way, you're a lot less likely to fall into pitfalls with these questions, because you got it sitting right there in front of you in black and white, or in this case, red and white, where one says equal, one says greater than, D cannot be determined. If they all said equals, C. If they all said greater than, then A, and so on and so forth. So what's the lesson to be had from today? Let's like sort of regroup, bring about sort of a conclusion. With your math questions, what tool should you be using on every math question? That wasn't really what I was going for, but that's a great point. Just like focus on the general things. Like if you get too much into like the nitty gritty of the questions and try to figure out equations, so like that's going to be a little bit harder. But I mean, what tool on the side? Like it's not on the computer, it's not the keyboard, it's your scratch paper. Yes, write things out. Plugging in is a writing technique. You don't just do it in your head. Plugging average pies, rate pies, ratio boxes, these quant comps. When you organize your thinking with writing on the scratch paper, you're not going to make those silly mistakes. Silly mistakes come from doing stuff in the calculator only or in your head only. You guys have done this, I am sure. What things have you forgotten about when you've done things in the calculator? It actually comes to mind. Somebody said, what was it? Something 0.67 for an answer earlier. How did that happen? That somebody came up with that? Yeah, so you accidentally type something wrong into the calculator, and when you look at that number, and if you were to write it down on your scratch paper, write that 12.67 on your scratch paper, and you would write it right next to your math that you showed, which was like 4.4 times 5, or I can't remember what the exact numbers were, and you'd see like, how the heck did I get a 2/3 from those two numbers? It doesn't work. And what it does is it goes like, it gets in your brain and goes like, whoa, hold a second. That number I wrote here on the left and that number I wrote on the right, they do not work together. They are inconsistent. And you're more likely to say to yourself, oh man, maybe I typed something wrong on my calculator. Let me go try that again. Or How many of you guys here have forgotten a negative sign? I can't count how many times. And that's a lot of times because you're doing steps in your head. But if it's written down and then you write it down, your answer right next to it, you go like, wait a minute. Oh, I missed a negative sign. Like it's this sort of check in. And if you're using that additional sense of using your hand and pen and paper, you're more likely to catch these things. So while I've shown you some strategies for solving questions, the other thing is the big major point here is the organization of work, because organizing your work and showing your work makes you a better math test taker. And like one of the things I first do with students that when I'm teaching them ACT and SAT is get them to write their work out. And you don't know how hard that is with a high school kid to like get them to write their work because they're so used to just like, and you probably are too, just plugging this stuff into your calculator as your first step, grabbing a calculator and start typing into it. And that just basically turns off your critical thinking skills of watching for your mistakes. So organizing and writing out your work, that's your task after today. I want you to show work on every single question unless it's ridiculously easy, like 1 times 1. All right, everybody got it?